AS Pure Mathematics, looking at an exam-style question for equations of circles in the form x minus a all squared plus y minus b all squared equals r squared, where the center of the circle is at AB and the radius is equal to r, okay, in roughly, okay, 7 minutes. Okay, let's go. So this is question 14, guys. The circle has the equation x squared plus y squared minus 6x plus 10y plus 9 equals 0. Part A, find the coordinates of the center of C. So we are going to complete the square. So first of all, I'm going to write it as x squared subtract 6x plus y squared plus 10y, and I'm going to subtract the 9, okay, on both sides, so it will equal to minus 9. I'm now going to complete the square on this quadratic and this quadratic separately, so I'm going to have x minus 3 all squared, oops, plus y plus 5 squared. Okay, remembering that we're going to subtract the square of this number when you complete the square. So minus 9, because 3 squared is equal to 9. Subtract 25 is equal to minus 9. Rearrange this, so add 9 to both sides, add 25 to both sides. You will get x minus 3 all squared plus y plus 5 all squared is equal to 25. Okay, if you add 9 to both sides, that goes to 0. Add 25 here, it goes to 25. Okay, so the coordinates of the center C, so C has the coordinates, okay, of 3 minus 5. Okay, so you flip the sign inside the bracket. Okay, so x is 3, y is minus 5. Okay, the radius is the square root of the end number. Okay, so the square root of 25, which is equal to 5. Okay, so that's the answer to part A, I, and II. Okay, part B is a bit more trickier. The line with the equation y equals kx, where k is a constant, cuts C at 2 distinct points. Okay, find the range of values of k. Okay, so to work this out, I'm going to sub in y equals kx into my equation. Okay, so I'm going to have x minus 3 all squared plus, so replace y with kx, so kx plus 5 all squared is equal to 25. Okay, so I'm going to expand the brackets together, okay, make it equal to 0, and then I'm going to plug the A, B, and C values into my discriminant and make that inequality bigger than 0. Okay, so that's my aim. Okay, so expand the bracket, okay, and then collect like terms. So this one here goes to x squared minus 6x plus 9 when you expand it in full. Okay, so sorry that I'm actually missing some steps here, but hopefully you're able to follow me. If you expand this as a double bracket, it goes to k squared x squared plus 10kx plus 25 is equal to 25. Okay, I'm going to subtract 25 actually over both sides. Okay, so that's going to go that will equal to 0. Okay, so this will now equal to 0. Delete this. So this quadratic here will equal to 0. I'm now going to combine my like terms. So I've got an x squared and a k squared. Okay, so I'm going to write it as 1 plus k squared x squared. Okay, yeah, so if you combine the like terms and then factorize it, and then I'm going to have plus, okay, I'm going to write it as, okay, something x is equal to 0. Okay, so I'm going to have, so I'll write it as 10k minus 6. Okay, for that part is equal to 0. Okay, so hopefully that makes sense. Okay, I've factorized, so these two terms together, so the x squared terms together, so pulling out a factor of x squared, and then I factorized the linear terms together, okay, in terms of k, okay, and got to this expression. Okay, so I might have to do actually some like deleting here. Okay, so let's delete this part here now. So now, okay, I'm gonna label A, B, and C, okay? So A is equal to 1 plus K squared, okay? That's the coefficient of X squared, okay, in my quadratic formula. Okay, B is equal to 10k minus 6, and C is equal to 0. Okay, so that makes it obviously a bit more easier because I'm going to have B squared minus 4AC. Okay, so I want the discriminant to be greater than 0, and the reason for that is so I have two distinct real roots. Okay, so okay, that's the key part. Okay, when the discriminant is bigger than 0, then I get two distinct real roots from my quadratic formula, okay, which is x equals minus b plus or minus the square root of b squared minus 4ac all over 2a, okay, because this part is being square rooted, okay, remember. So I'm going to have 10k minus 6 all squared is going to be bigger than 0, okay? The reason for that is because when I do minus 4 times A times C, that obviously goes to 0, okay? Because C is 0. So this part goes to 0, okay, when C is 0, okay? So this is a bit more tricky here. So if I solve this, okay, when is this quadratic here obviously bigger than 0? When it crosses, okay, so it touches the axis at 6/10. So when you set obviously this equal to 0, okay, or 3/5, okay, or 0.6, okay. So it touches, okay, that point there. Now that's going to be 3/5 there. Okay, so this, it's actually quite like a nasty question here. So think of this here as so this is not actually my intersection, okay, but this is where the quadratic, okay, crosses 0, okay. I think I might have been like a little actually mistake here, guys, if I'm not mistaken. No, I think that's actually right, yeah. But anyway, so when is this graph obviously above it? So it's above it, okay, when k is less than 3/5, but it's also above it when k is greater than 3/5. Okay, so k can never equal 3/5 basically. Okay, it has to be less than 3/5. Okay, and or greater than 3/5. Okay, which sounds bizarre because you might be thinking, well, how does that make sense here? So I may have made like a little mistake here. Okay, so please obviously point out to me in the comments section. Okay, but so the idea of part B is you sub y equals kx into this equation, okay, and form a quadratic in terms of, yeah, x squared here and x here, and obviously a constant here, and obviously k squared here and kx, okay. So you want the discriminant to be greater than 0, okay. Now when I did this obviously here, so this is actually called like a repeated root here, okay. So it actually touches the axis here, it doesn't actually cross it. Okay, so when k is less than 3/5, okay, it will have two distinct points, and also when k is greater than 3/5, okay, but k cannot equal 3/5. Okay, so k cannot equal 3/5. Okay, so I'm going with that, okay, as my answer. So sorry for actually waffling there, but hopefully that makes sense. Okay, if I have made a mistake, guys, obviously let me know in the comments below. But that's my idea. So you substitute y equals kx into the equation of a circle to form a quadratic in terms of x squared x here, and obviously k and x. Okay, you want the discriminant to be greater than 0. Okay, so you want the discriminator to be bigger than 0, so you have two distinct real roots, okay, and that's how you come here. So I must obviously made like a mistake here when obviously I expanded the bracket or completely the square, but that is what I got, guys, there. So let me know in the comments below here if you've got a different answer, okay, or let me know where I made my mistake, guys, here. But again, this is a super hot topic, so please share, like, revise this topic, guys, okay. Thanks so much for watching, take care, all the best, okay. Sorry for